Okay guys, we're starting this video off with a demonstration of how the GPS can be sent over the air. We're using two VHF radios right now to do the test. My GPS is over here in the windowsill out of frame, but it's coming over here in the output. The serial output is coming here to my Arduino, and the output of the Arduino is coming here and going into my my modem. And it just so happens that I inherited a whole bunch of these old inventory tracking things, and they weren't being used anymore. But they had a nice little CML MX614 chip, and I'm going to go into that in detail later. But basically, it's just an FSK modem chip. It changes 1200 baud data into a series of 2400 and 1200 hertz tones back and forth, and it's at 1200 baud. It's low enough speed you can send it across a standard radio channel, and without much difficulty. They do make, and I'm referencing in the video, a commercially available modem. A company called Tigertronics makes these. This is like the mobile version, this is the base version, the same board inside, but they're only like 65 bucks a piece. And even though they scratched off the chip information here, I'm fairly certain they're using the same chip here, or something very similar to it. It's the old Bell modem 202 standard. It's just like it's been around for 1,000 years. It's the same thing that the telephone modems use. But anyway, this is the basic setup, and I just got a raw push-to-talk switch over here, and the FSK audio coming into the input of my microphone on my mobile radio here. This would represent just your standard vehicle out in the field. On the receive side at the base, all you need is just another little modem to take the audio output of your radio and turn it back into the RS-232. But this is the basic setup, and it's a continuous loop of just that one GPRMC sentence over and over again. And so the user only has to sit there and hold the push-to-talk for a few seconds to let a couple good sentences come through so you can get a good decode. Now I'm going to switch over to the computer screen over here to show you what it's like when it comes in. So let me get that pulled up here, and we're also going to go with the Google Maps. So and let me find the you got to make sure you get the GPS thing here. There it is. Okay, I was just hiding underneath. This is in the Spectrum Lab is the program that I'm using. There's lots of these NMEA sentence decoders coming in. I've come in and I've got it configured to my COM port at 1200 baud, and basically whenever it sees a good sentence come through, it'll give you a decode here, and it'll give you your Latin long, and then what I do is I just cut and paste it and drop it over here into Google Maps to get a precise location. But that's the procedure here. So I'm going to go ahead and key it up here, and you'll see it come across. And there we got a good position lock there. You can see it came up. So now all I have to do is come in here and Control C and Control V here and drop it in and search away, and off we come, and there it is. So yeah, really easy to do, and when you're done with that, you can backspace out over again and come in and drop another one in from somewhere else, and there you go, you got your new location now. So it's nothing fancy. It's just just location, but that's 98% of what most people need with these kinds of scenarios anyway. So, all right. Well, so there's your demo, and now I'm going to cut off and go into all the details and go over those one at a time to kind of give you a run through. But there it is in action. So stand by. Okay, let's take a look at a overview of the system here. I have, starting on the left with a Garmin GPS, and it's putting out the GPRMC sentence at 38.4 baud at once a second. And that data burst goes into the Arduino Mega here that turns around and retransmits back out at 1200 baud. And then that 1200 baud signal goes into the radio modem here, and it changes it to a series of tones alternating between 1200 and 2400 hertz. And then that audio is sent into the radio microphone input, where it's played just as normal audio would, with nothing fancy about it. And we're sitting about 60% deviation on that. That goes over the air, goes to the receiver on the other side, where the audio comes out. And now those that FSK tones are switched back into RS-232, and then that that sentence now is brought into your computer through the serial port. Now I'm using two programs here. I have the Spectrum Labs, and it has a GPS receiver function on it, and you set it up for the COM port 1 and 1200 baud. And as the sentence comes in, and if it's a legit sentence and it passes the checksum at the end, it'll give you your coordinates up here in whatever format you want. And then it's just a matter of cutting and pasting from here over to Google Maps and hitting search on Google Maps. So this is the procedure, and I'm going to switch screens here as the train comes by. Just wanted to go over that the modem is based off of this chip here, the MX614, and these are still widely available and easy to use. I also wanted to bring up the actual schematic showing how it all goes together here, with the particulars and ins and outs. This circuit over here is that MX614, and I found this in another device that was doing a very similar function, and this is a little bit more detailed description of the circuitry that you would need to go with this chip, more than the chip one itself, and it much closely resembles the one that I have, that was already, like I said, already pre-built, that I just had a bunch of them laying in a box. So anyway, that's for the 614 modem chip, but like I said, the Tigertronics makes the ones, they're cheap, they're only $65, that are ready to made, and so you don't have to worry about messing with any of this stuff. You can just wire them in together. I'm also getting a container box for the Arduino, so I can put that into a secure thing with the TTL, the 232 converter here. And yeah, so altogether we're looking about $70 for the GPS, about $45.50 for the Arduino Mega, unless you want to get the other knockoff one for like $25. And yeah, the modem cheap, $65. So altogether you're looking at under $200 for the complete package. So that's considerably less than the market average. You look at ones out there on commercial radio systems, and they're generally they're around $1,000 turnkey for the whole thing. So quite a savings, and also this gives you the ability to interface it to any radio system because all you have to do is run it across the regular mic audio path. You don't need any fancy digital setups. So, all right. Well, I hope this helps, and good luck to those out there putting together their own package. We'll talk to you soon.